Hey everyone, today, we've got some mind-blowing news about antimatter that's straight out of a sci-fi movie. Imagine smashing billions of particles together at insane speeds and discovering something never seen before, the heaviest antimatter nucleus ever detected. This is huge, so, buckle up as we break down this incredible discovery and what it could mean for the universe itself. Welcome to Trendstorm. Chapter 1. A groundbreaking discovery. At the Relativistic Heavy Ion Collider, or RHIC for short, scientists were smashing together atomic nuclei to recreate the conditions of the early universe. From these high-speed collisions, they discovered Antihyperhydrogen-4, the heaviest antimatter nucleus ever found. This bad boy is made up of 4 antimatter particles, 1 antiproton, 2 antineutrons, and 1 antihyperon. The RHIC team sifted through 6 billion particle smashups, hunting for this needle in a haystack. It's like trying to find a single grain of sand in a desert. But their persistence paid off. They detected roughly 16 of these rare particles. That's right, just 16 out of billions. Chapter 2. What is antimatter, anyway? Now, let's quickly break down what antimatter is. Simply put, antimatter is the mirror opposite of regular matter. Instead of protons, neutrons, and electrons, antimatter has antiprotons, antineutrons, and positrons. When matter and antimatter collide, they annihilate each other, releasing energy. Here's the mystery, though. Scientists believe that both matter and antimatter were created in equal amounts during the Big Bang. But look around. Our universe is mostly made of matter. So, where did all the antimatter go? That's exactly what researchers are trying to figure out. Chapter 3. Why this discovery matters? So, why is this discovery of Antihyperhydrogen-4 such a big deal? It's all about understanding the matter-antimatter asymmetry. Right now, our universe is made up of matter, not antimatter, and we still don't fully understand why. The RHIC's discoveries give us a glimpse into the properties of antimatter and how it behaves under extreme conditions. By comparing antimatter particles like Antihyperhydrogen-4 with their matter counterparts, scientists hope to uncover clues to why matter won out in the cosmic battle. As Junlin Wu, a star collaborator from Lanzhou University in China, said, "Why our universe is dominated by matter is still a question, and we don't know the full answer." This discovery gets us one step closer to figuring out that puzzle. Chapter 4. Detecting the heaviest antimatter. To spot Antihyperhydrogen-4, scientists used a house-sized particle detector to analyze the collision debris. One of the decay products of this antimatter nucleus is Antihelium-4, which was already discovered by RHIC back in 2011. But the new twist? The Antihyperhydrogen-4 also decays into a positively charged particle called a pion. By retracing the paths of Antihelium-4 and pions, researchers could figure out where they came from. After sifting through billions of collisions, they found 22 candidate events. And after subtracting the noise, they narrowed it down to about 16 actual Antihyperhydrogen-4 particles. Pretty mind-blowing, right? Chapter 5. What does this mean for matter-antimatter comparisons? Now that we've detected these heavy antimatter particles, scientists are comparing their lifetimes with those of matter particles. For example, they looked at how long hyperhydrogen-4, the matter version, sticks around compared to its antimatter twin. Spoiler alert. No major differences were found. And while this doesn't explain the matter-antimatter imbalance, it's actually good news. It means that the current models of physics still hold true and we're on the right track in our understanding of the universe. Chapter 6. What's next? What's next for this groundbreaking research? Scientists are planning to measure the mass difference between particles and antiparticles to further explore the subtle differences. This is where things get really exciting. If they detect even the smallest difference, it could have profound implications for physics and could potentially unlock the mystery of why we live in a universe dominated by matter. So, there you have it. The discovery of Antihyperhydrogen-4 is not just another milestone, it's a giant leap in our quest to understand the universe. We're closer than ever to cracking the code of why our universe is made of matter and not antimatter. Source: Brookhaven National Laboratory. What do you think? Could this discovery lead to even bigger breakthroughs in the future? Let us know in the comments below, and don't forget to hit that like button if you enjoyed this video. Make sure to subscribe and hit the notification bell so you don't miss out on any future updates on this thrilling antimatter adventure. Thanks for watching, and see you next time.